Hi, welcome to Science Rocks. I'm Liz Heinecke, the kitchen pantry scientist, and I am also an author and a science communicator. So today I'm going to tell you about a scientist named Agnes Pockels, and then we're going to do a fun hands-on project related to her work. So, this project is from my book Chemistry for Kids, which you should be able to get at your school library. And I am going to start by reading you the biography or the life story of Agnes Pockels. Now, I have her picture here for you, and this portrait of Agnes Pockels was done by my illustrator, Kellyanne Dalton, sort of showing you how you can combine science and art together, right? Okay, so let's learn about Agnes Pockels, and then we are going to do some science. Agnes Pockels, kitchen sink scientist. Agnes Pockels was born in Venice, Italy in 1862. Her father was an officer in the Royal Austrian Army, but when she was 9 years old, he became very ill with malaria, which is a mosquito-borne illness. Her family moved to Brunswick in Lower Saxony, which is part of Germany. Although she attended a high school for girls and was fascinated by science, women were not accepted into universities at that time. She wanted nothing more than to continue her studies, but was forced to remain at home to take care of her two ailing parents while her brother went off to college. Fortunately for the field of chemistry, Agnes's curiosity was unstoppable. She began to notice interesting phenomena while washing dishes in her kitchen sink. Fascinated by how oils and particles formed films on water, she observed that those films could be disturbed by soap and other materials. Agnes transformed her kitchen into a research station and dove into the study of surface tension, which is the name for the way molecules stick together on the surface of a fluid. Her brother, Frederick, who was studying science at the university, recognized his sister's hunger for knowledge and supported her in every way he could. Besides observing her work, he gave her access to a physics journal so that she could learn what other scientists were doing in their more well-equipped laboratories. By the time she was 20, Agnes had invented a slide trough, which allowed her to play with the way a liquid surface behaved by sliding a wire or metal strip across the top of it. She used her apparatus to create very thin layers of fluids and then to test the effect of different contaminants, such as fine powders, on surface tension. Besides discovering methods for applying uniform layers of particles to a surface, she discovered that her trough could sweep a surface free of contaminants. Agnes shared her results by writing a letter to another scientist who also studied the surface of liquids. He was impressed, and eventually her work was published in the famous journal Nature. She was delighted to learn that other scientists were now using her research and trough design in their own laboratories. Pockels continued studying surface tension, and her work led to many discoveries and innovations in surface tension research and materials science. Agnes Pockels' brother died in 1913, and following World War I, her beloved physics journal was no longer published. She lived out the rest of her life in relative obscurity, that means no one knew who she was, always helping others. 4 years before her death, Agnes was awarded the Laura R. Leonard Prize of the German Colloid Society for her quantitative investigations of the properties of interfaces and surface films, and for the methods she used, which have since become fundamental in modern colloid science. So, what that tells you is that Agnes Pockels grew up in a place where she faced a lot of challenges that made it hard for her to do science, but she never let anything get in the way of her curiosity. And by following her passion for science, she actually accomplished some amazing things and became a rather well-known scientist, even though she didn't have much education or many advantages. So I love that she started doing science in her kitchen sink. And dish soap was sort of one of the ingredients that she also used. So we're going to do this project that I call tie-dye milk. And what it shows you is how water molecules, like the water molecules that are in milk, love to stick together. And they stick together because they're charged particles. And they love to stick to each other more than they love to stick to the air. So if you pour milk, like a shallow layer of milk, into a plate, like I'm doing, what happens is all the water molecules in the milk are sticking together at the surface of the milk super tightly. And in doing that, they make almost a film over the milk. You can kind of imagine like the rubber on a balloon. And what's happening is they're holding tightly together, so it's kind of hard to break them up. And you can see this if you take some food coloring, and this is the fun part. So take food coloring. Of course, you'll want to use all 4 colors if you have them. Drip it into the milk. And I don't know if you can see this from where you are, but you'll see it when you try this experiment. When you put the food coloring in the milk, it doesn't move around much. It just sort of makes polka dots. I can kind of see where the milk is under, or where the food coloring is underneath the milk, but it just sort of makes polka dots on the surface. So what's happening now is I have this milk, and the surface tension, this film that's formed at the surface of the liquid, is holding all the molecules together. And that's where the soap comes in, so dish soap. You can either use straight dish soap, but I like to add it to some water. So I'm just putting a big squirt of dish soap into some water. I'm using cotton swabs to do this, but you can use whatever you want. You could use an eyedropper, you could use a pencil, you could use your finger, whatever. So mix some dish soap and water together. And what we're making is essentially almost like a liquid knife. And what this is gonna do, when we put dish soap, when we touch the dish soap to the surface of the liquid, it's gonna break the surface tension. It's gonna pull those molecules apart and disrupt them. And what's gonna happen is then the food coloring is free to move around on the surface of the liquid. So hopefully you can see this, but what I'm gonna do is I'm just gonna touch some of this soap to the liquid of the milk, or sorry, the surface of the milk. I'm not gonna stir it, I'm just gonna touch it. And when you do this at home, you'll see how cool it is. Can you see that? The second the soap touches the milk, it breaks the surface tension, and the milk, the food coloring, swirls around to make these beautiful patterns. It almost looks like tie-dye. So that's a project that you can do at home that's kind of similar to what Agnes Pockels was doing in her sink when she noticed that if there were like particles on the dishwater and then she put soap in, it would make the particles scatter. So remember Agnes Pockels, famous scientist, faced a lot of challenges but went on to do great things. Try this hands-on project, and as you're doing the project, think about what else you could try. What would happen if you drip some oil in there? Anyway, that is your Science Rocks project for today. Have fun.